Hey everyone, welcome to the stream. So let's continue where we left off in the last stream. So the last time we were trying to refactor this code for the tokenizer so that it returns the tokens one by one when we call this advanced method. I think we did it fairly well. We have this advanced method. It will return the token one by one in an order. So we have taken care of the tokenizer. Okay, so now we need to create the compilation engine methods. Yeah, so let's figure out how to do that. Okay, so according to the grammar of this Czech language, we have to create an output of this kind, which is in the form of XML, which has a hierarchical structure. So this is just for the while statement. This just for this line of code, this will be the output. Okay. What are we doing in the file? Let me check analyzer. Okay, we are opening up the file for the input. Oh, wait. So for now we are not just opening, we're just opening a file. What if we pass a directory? So we still haven't created the logic for this directory input. Okay, should we do it now or figure it out later? Well, it doesn't matter, we'll do it later. So for now, let's just focus on one file. So when we give one file as the input, what we are doing is we call the tokenizer on that file path, and we get the tokenizer object, and we call the advanced method on it. The advanced method just gets one input, so this was just for testing of the tokenizer. But for now, when we are creating the compilation engine as well, we don't need to call this advanced method from here. Okay, we'll call the advanced method from the compilation engine. So let's open up the compilation engine. What should we create when we call the init method? What should we place inside the constructor of the compilation engine? Okay, so this is the output file. No, wait, this is the input file. But now that we have created the advanced method, we don't need to take the token file as the input. We can call the advanced method, so we won't be needing this. And let's get rid of this line as well. right? Okay, so this is an overview of the parsing process. Parser consists of a set of compilers. Okay, so we need to create this kind of methods, compile statements, compile if statement, and so on. And the code inside this method will be according to the grammar. We have to do this recursively. Okay, and we'll read the tokens one by one using the advanced method. So for all the source code files, the first method which will be called will be the class method, compile class method, because that will be the first keyword in all the files, in all the check files for that matter. So I guess in the no, wait, let's see, we'll need to check the API. Okay, so in the constructor, I think we might need to get this XML output file. Okay, we can take care of it later. Okay, so handling input that correspond to terminal rules. Okay, we have already written the tokenizer, so we don't need to worry about these things. Okay, so according to the API, the next routine must be compile class. So inside this, let's just do pass and create a compile class method. Alright, so this must be the generic logic of this compile methods. Okay, so for this compile class method, we need to look for the corresponding grammar. So let's find out where it is. It is this one. So this is the grammar for class. First there will be class keyword. After that, class name. Class name again will be, according to this grammar, it will be an identifier. And for the identifier, I think we don't have a method for identifier because it is a token by itself. After that, we have open a curly bracket, then class variable description. Wait, what is this? Yeah, so the declaration of class variables, and after that declaration of subroutines, and then we will have ending. Yeah, so the class variable declaration. Okay, that is all right, but so this eat method is supposed to take the terminal token, I think, and print the XML code. What exactly is this doing? eat, we pass this while if current, what the hell is this? Current, it is not less than or equal to or something. What the hell is this then? Is it checking that current token is string or not? No, probably not, because then why is it showing error over here? I think when we call this method eat, we are supposed to print this while as a token mostly. So when we call this compile class method, we should probably output this tag class tag. Should we do it over here? What the hell is this mashed up? Okay. Okay, let's suppose we just print this token class. After that, we are supposed to go back and forth between the grammar. So I need to check the grammar now. Code to handle the while, code to handle this, compile expression, code to handle. What the hell is this eat method doing? Maybe it is mentioned somewhere in the API. Check. So the output is generated by a series of compile routine structure according to the grammar rules that define X. Each compile X routine is responsible for handling all the tokens that make up XXX. Okay. Advancing the tokenizer exactly beyond these tokens and outputting the passing of XXX. Okay, all right. So let me open up the grammar then. So I think this is the complete grammar. Yeah, this complete grammar. So after we have printed this token for the class. Oh, wait. Oh, hey Detax Mango. After a long time. How are you, man? Software sales engineer finished. Well, I don't know because I don't know who your friends are exactly. I think from the interactions I had with you, you surely know a lot about security and data science, much more than me, mostly. Software and sales engineer, and I don't think that the software engineers mostly know about security and the data science aspects, unless they are themselves the security engineer or data science experts. So yeah, you must be knowing more than your friends, I think. But why do you want to know that? Huh? No, man. I really don't know that much. So yeah, for security, I think I know a bit about the web security and stuff. But for data science, I don't think I know that much. They're lying when I ask them. So what kind of questions do you ask them then? The technical kind? So if they know about it, then they might not be lying. They might tell you exactly what they know. What are you working on these days? On data science stuff or security related stuff? Okay, so according to this analyzer handling input that correspond to terminal rules. If the parser encounters a terminal element of type keyword, symbol, integer, constant, string, constant, or identifier, in this case the parser generates the output terminal element xxx and terminal element. Okay. Well, I asked what are you working on these days? Are you working on data science related stuff or security related stuff? Like what time series? Oh, so I guess data science related stuff, right? Time series, you mean LSTM and stuff? Oh, damn. I don't even know what that means. parser reserve finish colorization. I have heard that term for the first time. Vector optimization. I wouldn't know if this is important or not because I have come across this term for the first time. So see, you already know a lot. What's the issue here? But why are you asking if you know more than your friends or not? What exactly are you confused about? What the heck? Are they hacking me? But why do you think they are lying to you? Why would they lie to you? So you said your friends are software engineers and sales engineers, software sales engineers. Why would they lie to you? Why would you mean the software engineers? Why? You knew the data science, they would work as a data. Yeah, exactly. If they are interested in data science related stuff, they might be working as data scientists as well. Or maybe they just like the traditional coding aspect more than the mathematical scientific data scientific aspect of coding. You clearly like the mathematical aspect of it, from what I can tell. Yeah, sure. Okay, so according to this logic, if the parser encounters a terminal element, it should output this kind of output. The parser encounters a non-terminal element of type class declaration, class variable. But even the non-terminal element might contain a terminal element, like, because at the end, all of this, even non-terminal elements, are made up of the terminal elements, right? So at the end, we have to do this anyway. I think because this is recursive in nature, that must be the reason why I can't wrap my mind around it. In the third type, handling inputs that correspond to non-terminal. Okay, if the parser or counters a non-terminal element of type, class name, subroutine name, type, element of type, but what type are they referring to here? Okay, class name, subroutine name, variable name. In this case, the parser handles it directly. This is kind of a statement, let statement. So in this case, we shouldn't use the recursion. Instead, we should print all of them at once. Is that so? Yeah, I think. Okay, so let's try to write. Where's the grammar? Need to open up a new tab just for the grammar. Do we need this I language? I think not. Let me close this as well as this one. And in the third tab, we will open up the grammar for the reference. It seems that most of the time I'm wasting in scrolling through these slides. Where did the grammar go? Okay, this over here. Yeah, so when we come across this, what the hell? Okay, so we are supposed to print this tag, right? And I should probably write a new line character. Good. So after that, okay, I think after this, we might need a tab character as well. So then the next line of code is indented. It's okay if we don't indent it, but let's just indent it just for the clarity. Alright, so first we print this class tag, then we come across this class. Yeah, so that is exactly the token right now. So according to this logic, so now we should probably print the keyword. So when we come across this class token, it is a keyword as well as a non-terminal rule. So it is non-terminal in that sense that it contains other statements inside it, other body inside it, but it is terminal in the sense that most software engineers don't learn. Yeah, most software engineers don't learn machine learning. Because most of them, because I heard that most don't even like when they start machine learning, because in although it is kind of part of software development, but it feels like it is like totally different thing compared to the traditional software engineering. Even I feel that, because for machine learning you are mostly creating the models and optimizing it and all that, so there's not much hardcore logic in, like there's no logic, but most of the things are intuitive in nature, so that's why I think most of the software engineers don't like machine learning. And that is true for mostly the front-end engineers, the front-end web developers, because they don't like mostly machine learning because it involves a lot of mathematics. So I think that's the reason why software engineers don't learn it, most of them at least. But according to me, I think every software engineer should at least try machine learning, because even though it is totally different than the traditional aspect of software engineering, it is still a new, like totally new dimension of software development, like data driven one. They should at least be familiar with how it works. What do you think? So we are storing, what is it? We are storing the whole token, including the tags inside the token. So when we call this advanced method, it will give us the whole token, including the tags. But we also want to know the type of the current token, right? And to know the type of the token, we are passing the token. Now this token is just the token value, not the whole text. So we probably need to change this, or should we? Should we store the tokens without the tags? I think, yeah, that might be so, because when we come across a token, we need to know the type of that token as well. So we are going to call this method token type anyway. So either we can pass the token in this form to this method token type. Wait, then we'll have to change this as well. Let's check the API. Let's see what they are suggesting. This according to this tokenizer API. Working at big tech usually end up in 300k, 200k. Well, I hope so, at least, because most of the engineers say so, that big tech companies pay that much. But I think for that you have to be a senior developer or something like that. Is that one of your goal, to get into big tech company? Ignore all comments and white spaces and then push stream and serialize it into check tokens. What do you quant trading is? Oh, okay, quant trading. So still, but for quant trading, there are big fintech companies, right? At least not tech, but financial, big financial corporations. So that might be your goal, I guess. And I think in this era, most of the financial companies are using software as well. So most of them have roles for developers of that kind, right? It returns the keyword, which is the current token, as a constant. This method should be called only if token type is keyword. Oh wait, so we also need this kind of methods for keyword symbol identifier. So when we call this method, okay, and when we call this method, it should return in string character class method. Although, why should it return the capitalized version? Okay, it should be only called if the token type is keyword. So did you create any project these days? Any cool project of that kind? Do you at least have a portfolio site? I should. Yeah, you should. Do you at least have a portfolio, like a GitHub profile or something? Marcos book. No, I didn't. What are those for? Do you mean Marco Polo's book? The fiction one? Are you talking about this author, Ferdinand E. Marcos, or the Marco Polo? Marcos. Oh. Okay, so he must have written books on ML in the financial space, I guess, right? Operations, research, and information. Okay, so modernize finance using popularizing the use of machine learning and supercomputing. So yeah, I was talking about this only. So most of the finance these days, I guess, must be using machine learning and computing aspect as well. You might know more than me. I'm just saying. And what about security related stuff? Did you learn anything new in that space? I'll be right back in a minute. Wait up, I will be right back, okay? So I was saying, did you have a do you have a portfolio site, like a GitHub profile or something else, a website maybe? We also need a current token, and this will be empty initially. Okay, and also in this case, instead of writing the whole token, we should write the token value only, not the token type. So let's get rid of this. What the hell? Let me just do it manually. Software engineer. Well, I don't think so. If the software engineer knows if you have to spend 10 hours a day, well, it depends what kind of software engineer he is. So if he's already a web developer, even though if he's a web developer, he needs to know what kind of vulnerabilities exist in a web app. So you first need to learn what kind of vulnerabilities exist in a web application, and after that he can, and that's not it, because you need to learn how to use different tools which are used in the bug bounty space, like for web development, for the web apps mostly. This tool Bobsuit is like a Swiss Army knife for web hacking. So first of all he needs to learn this tool, and after that, if he after he learns a bit about this tool and what kind of vulnerabilities exist, so let me show you one thing. So this website Portsfigure, the Bobsuit tool is made by this company Portsfigure, and also they have lessons for web security. So they have a huge collection of all the different types of bugs that exist in a web app. So after, and first of mostly most of the bug bounty hunters, when they start, they don't focus on all the types of bugs. They mostly pick one bug, like say cross-site scripting or something else, and they learn a bit about it, like where this kind of bugs exist and how to find them, and they use the tools like Bobsuit and other vulnerability scanner tools to try to find the bug. So that's how basically how the engine is. So for web development, even though he's a even though a software engineer might have a background of creating web apps, you still need to learn this tool and the kind of vulnerabilities that exist, and after that he can start trying to find a bug. And even after that, it's very hard to find a bug because there's a lot of competition. There are many experienced bug bounty hunters who are working on most of the websites, and or most of them have, you know, the automated system which picks out the low hanging fruit. Like all the low hanging fruits are automated by those bug bounty hunters. So the bugs that are remaining are quite complicated. So it's quite hard to find a bug, at least in the web development space, web applications, because most of the bug bounty hunters starts with web applications. And as you go down the complexity, like if you start hunting on, let's say, mobile applications, then the competition gets a bit lower. And if you again go down a bit and start hacking on, say, blockchain applications, the competition gets down a bit. And the lowest stage, I guess, is binary exploitation, because binary exploitation requires a lot of knowledge before you can start hacking binaries. You know, you need to know a bit of assembly language as well, and how to reverse engineer binary and all of those things. So yeah, so bug bounty space is quite competitive. It contains a bit of competition. But most of the bug bounty hunters, they get their first bug after 2 or 3 months. All right, I will see you then. Okay, so now we're storing the token value inside the list, and when we call the advanced method, let's see, not only we want to change the current token index, we want to change the current token as well. So we will do self dot current token, and this will be self current down there, and we'll return the self dot current token after that. Okay, so this seems all right. Okay, let's check the API again. So this token type should return the type of the current token. Okay. Well, in that case, I have to remove this, right? So instead of doing that, let me give a default value. Default value is just empty. Oh wait, instead of default value, we can have what that. Instead of default value, let's instead of having an empty token as a default value, let's have the current token as the default token. Yeah, this will be better. So the current token will be the default token for the token type. So when we call token type without any token parameter, it will take the current token and return as the type of the current token. Okay, this is consistent with the API. Do we need this methods keyword? So inside this advanced method, we are only supposed to advance the tokens to the next tokens. We don't need to return the current token according to this API. Yeah. Or we can skip all of these methods. Okay, so it's saying over here that if the token type is string on, it should return the string value without the two double and closing double quote. So when we append this token, are we appending the quotes? String C is false. Well, I think we are appending the. Oh wait, yeah, we are stripping. We are stripping the double quote. We should probably do it here as well. When we append the token, we should strip the double quote. So 1, 2, -1. So in this case, we won't need to write this method. Okay, I think this is it for tokenizer for now. Okay, what should we do for the compile class now? Print the keyword class. And we should call this compile class from this. For this, I think we need to call that TKZ dot token type. This will return the token type of the current element. Okay, we should probably write a different function for printing the terminal element. Yeah, we should do that. So let's write a method called print, not print, generate over gen tag. Should I call it gen tag? Generate terminal print run. generate terminal L. Yeah, what should I call it? Let's just call it print tag. What this will do is first, yeah, it will do this. Get a token type. After that, it has to print a value of the token, current token. So we'll do tkz dot wait, we should probably have a method to get the current token as well, right? Right, what are we doing in the advanced method? Let me check. Yeah, we are returning the current token in the advanced method. So we can call the advanced method here. Wait, but then it will also lose the token type in this case. So we should probably store it inside a temporary variable t type. And here we should just print the t type. Wait, that's the problem. So when we call the advanced method, right, so we should call the advanced method first. And store the token here. So this would be all right. We need a space. After that, we'll print the token and probably a space after that as well. Okay. After that, again we'll print this, including the ending slash. This should be for the print tag. We will call print tag here. Okay, so what should we do after that? So we might also call this advanced method here. That's okay. Let's just call it. So in the class, what should we do after this according to the grammar? We have the class name. So let's check the corresponding rule for the class name. It falls under the third case, I guess. Yeah, this for the third case, if the parser encounters a non-terminal element of type class name, the parser handles it without recursing. Oh man. So does this mean we are not supposed to write a method for class name? Is that so? For the class name, it is just an identifier. Man, this compiler is harder than I thought. Mostly because I'm trying to conform my code according to the API. Okay, I see. So the let statement itself is not a non-terminal element of this type, the third type. It is this var name. Var name is of this type. Okay, I see. So for this case, we should directly call print tag again, I think. So what this will do is advance the token, and the next token will be the class name. It will print it simply. Yeah. Okay. Good. I think I'm getting it. Okay. And what will be the next token after that? According to the grammar of class, okay, it will be a symbol. And I think for the symbol, do we need the method for the symbol itself? Yeah, well, so it is a terminal element, so we can call print tag again. This will print a symbol. What will be after the symbol? We have a class variable declaration. Now this is of non-terminal type, so it will be of second type, so we need a method for it. So we should call self dot compile compile what? Class variable declaration. Yeah, class var tag. We will call this method. Okay, when it returns, we'll call. So the star means we need to check what the star means exactly. It might mean one or more or zero or more. I need to check. It was described somewhere around here. Yeah, just over here. So foot star indicates zero or more times. Okay, so we might not have a variable description. So we might not have a variable declaration in the class. Need to take care of those scenarios as well. So how do we know if we have a variable declaration or not? I think for that we have to check the token. If the next token is static or field, then we do have a class variable declaration. Okay, so I think we should probably have this logic. Holy. Star means zero or more. Question mark means zero or one. Okay. If we check this passing, Okay, I think we need to check the token first. We need to check the token first, and after that we have to call this method. So in this case, we should check if the next token complies with while statement or not. Not while statement. In this case, it is variable declaration. So if it complies with class variable declaration, then only we should call this. Okay. So instead of getting the token here, let's get the token here. So now we will check if token, well, we also want to know the type of the token. Token equal to class. Let's just assume it is class. We'll pass the token here. After that, we will call advanced method again. This looks dirty. I'm not really sure if this is the right way. Now after this, we need to check if token equal to so for class, this will print the class keyword. When we advance it, this will print the class name. Again, when we advance it, this will print the symbol. Now when we advance it, it will either give a token of this kind, class variable description kind, or it will be of subroutine type, or either it will be of this type. So we need to check what kind of token it is. So we can check it using if token is either static or token equal to yield, then we know it is of compile class variable description type. Okay, we have a problem because we have already advanced the token here. So when we call this method, we won't need to advance it, or else it will skip this static failure. Okay, so I think we should probably advance. Okay, it doesn't matter, we'll pass the advanced data token. Yeah. Or instead of doing this, okay, let's just do this. LF token is of subroutine description type equal to, let's say it is either a constructor or token equal to function or token equal to method. Well, in this scenario we should call, oops, we should call self dot compile sub routine deck and pass a token. What will be the third scenario? Because the subroutine description can also be 0 or more times, so it will be just this token. If it is none of this, then we'll just do self dot print tag. We'll pass the token, so this will print this bracket. Okay, this is correct. Okay, so now let's write this compile method, compile class variable description. Compile and for this method we'll pass the token. Right, and inside here we already have the token, advanced token. So what we should do probably, yeah, I should subroutine deck. Print class where, oh wait, I forgot something else. After we are done with printing the symbol, we need to print this again, the ending of the class. This is the ending tag. Here also we'll have a ending class variable description, and everything else will be here. Okay, so let's check the grammar for class variable description. It will be either static or filled. Okay, so here we need to advance the token. After that we need to check, well, it doesn't matter, we don't need to check if it is static or field, because both are types of keywords. So we can call self dot print. It was print, right? Yeah, oops. Okay, current tag, do we need to pass? Yeah, we need to pass the token. This will print static field. After that we have type. Wait, what is this type for? Do we have a grammar for type? Seems we don't have grammar for type. Oh yeah, it is here. It is just okay. So type is of third type. Third type of it. It comes under third type of rule. This one. Okay, so We'll again call this advance it and print it because type is of this type. And for the variable name, again third rule applies, right? Yep. So we'll again paste it. After that we can either have a comma and another variable name 0 or more times. Yeah, so we need to check. Whoops. We need to check if this token is comma or not. If token equal to a comma, in this case, what should we do? If there's a comma, then we know we have a second variable. Yeah, so we should call this and should do this 2 times again. This is for the variable name. Oh, wait up. So the star means it can be 0 or more times. So I think we have taken care of 0 or 1 times only. What if we have class variable declaration 2 times? So we haven't taken care of it. When we call this method, it will return from this method. Okay. We should keep calling this method as long as the next token is of this type, static or fill. So it seems we shouldn't really use an if statement. We should be using a while statement, right? So let's do that. While token is equal to, so when it returns from this, we should call token equal to tkz advance again. So this will give us the next token, and if this token is of static type, then we'll call this again. Same with this, while okay, this will take care of 1 or more times. I hope this will work. I'm not even testing the program incrementally. If this fails, we are going to have a very nasty bug. While token is equal to this, print a symbol, then advance the token. This will be the variable name, then advance the token again and check if it is comma again or not. If it is comma, then again do this. If it is not a comma, then you simply calls this. Right, and you pass the token. Okay, this is cool. After that, so it seems we have taken care of the class variable declaration method. Now we need to write the subroutine declaration method. Should we copy this? Well, I think it will be somewhat similar, so let's just copy this and we'll refactor it. So we should call this compile subroutine declaration. Compile subroutine declaration. Okay, so what we will do in this case, wait up, why are we advancing it for this? When we call the compile subroutine, we already have the token, right? Let me check. We should just print it. Yeah, we shouldn't advance it because we already have the token. We should just print it. Same for this case. We shouldn't advance it because we already have it. We should just print it. It will be either constructor, function, or method. After that, we advance it and we print it because it can be either of type void or a type, in which case we print again. So this will print constructor, function, or method. This will print void or type, and when we get the next token, it will be subroutine name. Okay, so I think let me check the rules. Subroutine name comes under the third case. So in this case, we should print the subroutine name, right? It is just an identifier. Right. So this was for constructor, this for void, this was subroutine name. Okay. We need one more for this rounded bracket. Then after that we'll have a parameter list. Let me get rid of this while. So this will print this symbol. After that we have a parameter list. It will be of this kind. Okay, so it is saying that we have a the parameter list is quite complicated. We need to check the rules. I think it comes in the second rule. Parameter list, yeah, it is a non-terminal kind of rule which comes under the second kind, parameter list. So we should call this parameter list. I think I should probably write the comment so that I know. So this is for constructor function or method. This is for void or type. Oops. And this will be for the subroutine name. Okay, after that this will be for the symbol. Parameter list. So we need to call self dot compile parameter list and we'll pass the token. Wait up. Parameter list, we need to call it only once, so we don't need a while loop. Okay, what should we do after that? We need to print this closing bracket. So let's copy this. After that we are supposed to have a subroutine body. Okay, so we will call, copy this, subroutine body. Compile subroutine body. Yeah. After that, we'll print this subroutine description. Okay, so now we need to create this compile parameter list method. Definition compile parameter list self and we have token. Okay. First of all, it should print parameter list tag. Okay, let's check it. So for the parameter list tag, we have a bracket which can occur 0 or 1 times. Okay. That means we might have parameter list or we might not have it. So we need to advance the token and check first of all. Right, when we call this parameter list, wait up. Yeah. So we need to check if token okay, so this might be problematic because the next token, when we advance this token, this token might be of this type because parameter list might not exist. So in this case, I think we should have a condition just here. If token equal to, well, not equal to this, then we have a parameter list, else it is this one. So in this case, we don't need to advance token. Good. So when we come into this method, we are sure that we do have a parameter list. Okay, so we can start compiling this. Inside the parameter list, we will have type variable name. Okay, can call self print tag and pass the token because this token will be of type type. After that, we will advance token, and this token will be of where name type. So we'll print it. Again, we'll have this kind of scenario. So let me copy this. We will advance the token. Token is of type comma and type where name, right? So this will be for the comma. We advance it. After that, we print it. Now this will be of type. Okay, this will be of type where name. We'll print it. When we are done with it, we will print parameter list. This is it for the compile parameter list method. Okay, now let's write the method for subroutine body. Subroutine body token compile subroutine body. Okay. You know what? We are supposed to write all of this to an XML file. So let's just get the output file. Self dot out f open. Okay, so now we need to give the name. So I think we probably need to pass the name when we call this. From compilation engine import compilation origin as engine as parser. Okay, so in this case we won't be calling the advanced method. Parser equal to parser, we will pass the tokenizer, and we should also pass the file name. So now we need to get the file name. Can use this path to take care of when we pass a directory. So according to this, if the input is directory, the output should be one XML file for every .jack file. So first we need to check if it is a directory or not. We'll check it in this condition. After that, we need to do all of the steps, but for all the files, all the jack files. So I think we need to search all the .jack files in the how to find files of specific type in a directory Python. Yeah, we can use OS walk. We also have list directory and glob. I can use this glob as well, but for that I think we'll need to use this glob module. Let's just use the OS walk method because we are already using the OS module. We can do for root files in os.walk kr. The path is this path. Right. And for file in files, if file dot ends with .jack, then in this case we'll call this method. We open up the file, get the tokenizer, and call the parser. Yeah. We have repeated this code twice, so let's create a module for that. Definition parse file. We should probably pass the path. Yeah, we don't need to pass anything else, I think. Now we can copy this lines of code. Yeah. And we can get rid of this. and call parse by the path. Wait, but I think we might have a problem, because for this case we need to pass the file name, right? So will this file name contain, okay, we'll check it later. Let me delete this. For this case we just need to call pass file and pass the path. The path will contain the file, but in this case the path doesn't contain the file, just directory. So we need to let's just, whoa, why is this messed up? Yeah, this is messed up. Let me comment out this code, and first print just the file. Okay, so now we'll call the jack analyzer, and in this case we won't be passing a file, we'll pass just a directory. So let's see what happens. Okay, it failed. The tokenizer self is not defined. Why can't we call it like this? Because because the self is here, that's why we can't call self like this. Is that so? How can we give a class variable as a default value in a class method Python? Yeah, this is exactly what we need as well. Okay, I'll do that. Alright, we need to open the tokenizer, and over here here we'll pass token is equal to none, and we'll check here if token equal to none. In this case we'll assign token equal to self token. Okay, the problem is solved. Okay, let's try to compile it. Whoops, invalid syntax. Why is this an invalid syntax? Well, we do have a compiled class method. And why is it saying this? This is an invalid syntax. We can call another method from here, right? Is the name correct? It seems all right. Oh, wait. Because of this thing. I get it. Tokenizer will be passing the path. Yep. So path plus will add dot XML. We'll open it up for writing. Okay, this might work. Before that, I need to check what should be the name of the output. Yes. So this main.t is this R for the tokenized, and we already have main.xml. Okay, so we should probably have path out.xml. This might work. Let's try to print the names now. Oops, print tag expected an indented block in the print tag. Oh yeah, it's because of this line. Good. All right, we have got this as the output. Now if we pass this expression list, we get square main. Good. Okay, it is working as expected. Okay, but still this is not the whole of the path. Yeah, we need to do this os.path join. We should join the path. Should we join the path or the root? Let's try to join os.path dot join, and we can join the root. Okay. Right, we are getting the whole path now. This seems correct. So now we can pass this, the whole path, as input to this function. We'll pass f path. So for all the files, we'll call pass file. Okay, now let's go back to this. Yeah, so what were we doing? Yeah, we got the output file. Now we need to write all of this. Instead of printing it, let's write it to the output file. So here we'll do okay. So now we'll do self dot out file dot write. Change print to self dot out f dot write. Okay, also need to do, and we'll do it here as well, and okay. After that, what was I thinking about? Wait, we change this as well. Yeah, need to change this G. Yeah. It should be here. Okay, this is correct now. Okay, 10. I will be right back. Change this as well. Okay, and we should probably close the file inside the compile method itself, compile class. When we are done writing the ending class tag, that means the file is over. So you can do a out file dot close. Okay, so let's get back to the compilation methods. We were trying to write, let me check, subroutine body. Yeah, so we need to write the method subroutine body, compile subroutine body. So for that, the token will be this one, opening bracket. So this should be subroutine body. Oops. For the subroutine body, the first will be the symbol. It will be printed. After that, we will do token equal to tkz dot advance, right? So this will be a variable declaration. So now we can have a variable declaration. Wait, what kind of variable declaration is this? Yeah, this is kind of variable declaration, and we can have 0 or more times this kind of variable declaration. So what should we do in this case? We need to check if the token type is var, but first we need to check the statements as well, because the statements might also contain this variable statements. So statements, okay, can either be a let statement, if, while, do, or return. So let will start with let, if will start with if, while with while, do with do, and return with return. Okay, cool. So we don't need to worry about if this statement starts with where or not, because only the variable declarations will start with where. Right, so now we can check if token check if it is a variable declaration. Token equal to var, that means it is a variable declaration. Wait, this should be while, because we can have 0 or more times this kind of variable declaration. So now should we have a separate method for variable declaration? Let me check. Variable declaration is of this type. Yeah, so we need a different separate method for variable declaration. Now what we can do is self dot call compile var back, and we'll pass this token. So this will be to call this. Wait, do we need separate tags for it? Yeah, probably. Okay, we'll call alright then. After that, after variable declaration, we are inside subroutine body, right? So after variable declaration, we might have statements. So okay, there's no, seems that yeah, we can have 0 or more types statements. So now we need to check while token not equal to this. Wait, but for statements, do we need a terminal? What? Statement comes under the third type of rule? Why? Statements contain complicated things. It contains an expression and statements and a subroutine call as well. Then how does the statement comes under the third kind of rule? I think this is incorrect. I mean, the statement is listed here. The statements is listed here, right? The statements are listed here, but statement is listed here. Why? This is confusing because again statements is again a non-terminal rule, and it can be of type let's, if, while, and those statements come under the second rule itself. So I think this shouldn't be here, probably the statement. Right, let's just roll with it for now. We need to check if wherever be subroutine body, we need to check if token, while token is not equal to this, we know it is a statement. Now this token might contain let, if, while, do, return. So I think we need to check it here only. If token equal to let, then we should call let statement compile method. Right? If token equal to if then we need to call if statement. Elif token equal to while, we need to call while elif token equal to do. In this case we should call, let me just write it, self dot compile do statement. Elif token equal to return, then call self dot compile return state. Compile if statement. This should, oh wait, this should be let. This is correct. This should be while. Okay. This should be return, not restore. Because we know that if token is not the closing curly bracket, then it's bound to be a statement. After that, what we'll do, right? Okay, so this wraps up subroutine body. We did take care of parameter list, and we have taken care of subroutine body as well. Wait, but parameter list contained, no, didn't contain anything else. So, but this subroutine body does contain this methods, compile let and so on. So we need to create those. Plus we still don't have compile variable declaration, so we'll start with compile variable declaration. Definition file where self token. Oops. This should be comma. Okay, what should we do inside this variable declaration? We need this kind. And this should be variable declaration. Yep, I think so. Variable declaration. Okay. Let's write the ending tags as well. Now let's check. We are inside the variable declaration. And we have already checked if the token is variable or not. So it means that when we are inside this method, the token is bound to be this of type var, or the token is variable for sure. So now we can directly call self dot print tag. Yeah. And this is for var keyword. After that we have, so token is equal to tkz advance. This is type. So again we can do print and we can do same thing for the variable name. Where name. Okay, so after variable name we can have another variable name. So now we need to check if the next token is comma or not, or we can check if next token, while the next token is not this semicolon. So it should be similar to what we had inside the parameter list, or like this one. So let's copy this. We will check the token is equal to comma okay, so in this case we might not have this type. We don't need this type. We are just having a comma and variable name. Wait up, but we are not advancing the token after that. So this, we had a problem, I guess. We were not advancing the token after this. Okay, so we might have a problem. How is it supposed to run this while loop when we are not even advancing after the variable name? But if we advance it, then that means this won't work. Okay, we might have a problem here. Okay, the problem is because of these two patterns, a star and a question mark. So the logic doesn't really pan out. So what we are doing here is we are printing the, or I should say we are saving this tag, which is a symbol tag. After that, we are checking if the token is this or not. If it is not, then we call the compile parameter list. Well, I can, where was it? I can take it out of this else, and it should be while. No, that won't be correct as well. Okay, so this is correct. We only need to modify this method. this method, in this while loop, we are not really advancing the token. Okay, but if we advance it, when we come to the last variable name, the next token will be this one. And if we are getting the token here, we should probably print it here. And it doesn't matter. Ooh, what the hell? Let's just go advance it here. And while here we'll check if while check it while I think we might have a problem. I mixed the operators. Do we have a not equal to? Yeah, we don't have a not equal to operator. Yeah, we do have it. What the hell? Do I get confused? And instead of checking for comma, we'll check for this symbol. And let's just wait. So here's the problem. We should print the, so now this token will be this one, right? When we come out of this loop, we need to print it somehow, and it won't be printed in this, where was it, in this loop, because it was printed only in the else case. When this compiled, the parameter list was empty. In this case, what should we do? This symbol is part of the subroutine description declaration, not the parameter list. So we should be printing it as a part of subroutine declaration. Yeah, but we can print. Yeah, this is a hacky way, but and it really messes up our pattern, but it might work. What we can do is call self dot int tag after this and pass that token. So it will print this, and it won't be part of the parameter list. It will be okay, it will be part of whatever called this method. Right. because there was no other way we could have taken care of this thing. This seems alright. Let's go back to, I forgot where were we, the variable declaration, but why did we jump to, yeah, because of this thing. Here we will also, we might have same problem. So we are checking if we are just getting the next token, while token, yeah, so this is incorrect. But in this case, you can just do while token, whoops, while token not equal to semicolon, yeah, we don't have this. And after that we'll do token is equal to tkz dot advance, right? And finally we'll print this, not print, we'll call self dot print tag, we'll pass the token. Okay, so this will take care of variable declaration. And now that we have taken care of variable declaration, we need to take care of compilate statement. And before we do that, let's just check we don't have any compilation errors. Wait, but for that I need to turn off this parsing. Okay, let's now check it. All right, so we don't have any compilation errors, hopefully. Let's go back to this. Okay, let's start. Now we need to write this compile let statement. compile let statement. Okay, so this should be let statement. Now let's check the grammar for the let state. It starts with let. Yeah, so you can directly print it. Self dot print you need to pass the token as well. Okay, now we'll do token is equal to tkz dot advance. This will give us the next token and it will be of type variable name, so you can print it directly. This will be a variable name. Right, the next. Okay, so the next can have this whole part 0 or 1 time. 0 or 1 time. What is it? Oh, wait up. So I think so now we need to take care of this thing because the expression is a bit complicated thing. For the let statement we can have our variable name, then this brackets, so the variable might be an array, and if it is an array it can have an expression inside it. Now this expression can be of this type, a term of term. So I think this is the first time we have come across an expression, and again this term can be of this kinds. So now to check if this term is falls under any of this, okay, we'll take care of term later, but let's see. After we have printed the variable name, you can do token dot advance. Now we need to check if this is zero or 1 times only, so we need an if statement. If token equal to this, then we know we have this whole term, and first Well, we will just print this. Wait, did I mess up something? So we are printing the let variable, let keyword. After that, we are advancing the token. We are printing variable name, advancing it again. Yeah, so it is correct. After that, if the token is this, let me get this. We print it, and after we have printed, we are bound to have an expression. It can't be empty, right? Yeah, it can't be empty. We're bound to have an expression. So we'll call self dot compile expression. Now for expression falls under second category, second rule. Yeah, it falls in the second rule. So we'll be having a compile expression method. We will pass the token. Wait, which token will we be passing? I think we should probably advance it first. So yeah, we should do token is equal to pkz dot advance this is correct. Should we advance it here? Yeah, I think this is correct. Okay, so we'll do advance and then call the expression compile expression. This method compile expression will probably be the complicated one, the most complicated one. Let's just take care of it later on. Okay, but when we return from this expression, what will be the next token? Because we should probably print this closing square bracket in this method only, because it is part of the let statement. But In the expression we have the star, so we'll be having a while loop. Let's just let's just print the token for now. Let's advance it and print it here. Expression. Token is equal to tkz advance. This will be a closing square bracket, and we'll do self dot print tag token. Okay, so after that this is over. The if block is over, we'll have equal to. So after that we'll advance the token. We'll print equal to. Again we can have an expression, right? It can't be empty. We are bound to have an expression, so we need to do this. We need to advance the token. After that we call the expression again, right? And finally we will print the semicolon. And that will be it for the let statement. Okay, now we need to write if compile if method. Compile if, that's the next one, right? Yeah, if while do return. Compile if statement. Token. So now we have compile it. It will be almost similar to the let statement. I'm saying almost. So we do need to print the first token and the second token as well. So let's copy this. This will be if, and this. After that, we'll be having an expression. So let's copy this. We will have a closing bracket. Okay, after that, what? We'll have a curly bracket. Again, we'll, oh wait, so after that we'll have statements. So we need to call compile statement. Whoa, no. We need that if else condition again, so we need to advance it and check if, yeah, so we need to copy this if else. Where was it? Yeah, this one. Yep, this one. We'll advance the token, and while this token is not this closing curly bracket, we'll check this conditions and advance tokens. I think we should have been doing the same thing for compile expressions as well. In this thing, where was it? Yeah, here. Okay, let's worry about it later. Let's just complete if statement first of all. While the token is not curly bracket, Okay, after this what? Then inside the if, right? So we will be having a rounded bracket after that. It's not yet over. Rounded bracket, we'll print it, and after that we'll have else. Okay, so we'll need to print it as well. Okay, we'll have again statements. So we should do this thing again. To this point. Right. Oh wait, the whole else part can be 0 or 1 times. Oh, okay. Let's just copy it. And we should run it only if we have an else. And this was incorrect. Wait, yeah, this was incorrect. What was incorrect? After the closing curly bracket, where was it? After the statements, we had a closing curly bracket, and this is not a keyword. Sorry, it's not. Is it a token? It's not a token. It's part of the grammar. Token is else. So let me delete this. Now we need to advance it and check if we have an else or not. If we don't have it, we don't need to do these steps. So if check if token equal to else works, only then print else and do all of this stuff. So this should be like this. Okay, but that's a problem now. When we advance it, suppose if it is not and else, in that case what? Well, I should probably have a feature inside tokenizer to go back. This might solve all of our problems, because we might need it for this thing. Let me check. Yeah, we might need this for this. So what they are suggesting for this case is we should save the current token and advance to get the next one. How the hell are we going to save it? Well, instead of saving it, because of the way we have structured the tokenizer, we can go back as well. We can have we have an advanced method. We can have re-advance, no, backward method. Yeah, let's have a backward method as well. Backward. What this will do is it will do self.current index -1. And self.current index is greater than or equal to 0. Okay, so now what we can do here is, instead of printing it this inside this parameter list, we can do it inside this subroutine body as well. and I can call token dot backward here. Page name backward. Yep. And now where were we? For compile, let compile if, yeah, so this. So now we have a possibility of looking ahead and looking backward. Good. What will happen here is we'll first advance the token and check if it is else. If it is else, we'll go through all of this motion. Now if it is not else, that means it is a different statement, or whatever it is after a statement, whatever comes after the statement. So that will do TKZ backward and end the if. Good. So we have taken care of it, and I think now we can take care of this expressions as well. Yep. Okay, so where are we now? We have written the if statement, compile if. Now let's write compile while statement method. Compile while statement okay. So this part, it will be similar, I guess. Wait, it will be similar up to the statements, so we need this as well, but we won't be having an else part, so this is it. We will paste it here. This should be while then rounded bracket, we have expression, call advance, and then expression, and that will end with the closing rounded bracket. After that we'll open up with the curly bracket, then we'll advance and check if we have any statement or not. And we'll print this. Good. Awesome. So that was easy. Now we have do statement. Compile do statement yourself token. Let me copy this. Okay, this should be do statement, right? Okay. Compile do statement. Or compile do will print the do part. After that, okay, we have to call the subroutine call. Now the subroutine call, yeah, it is bound to be inside the second rule. Subroutine call, well, is it? Whoa, it's it falls in the third type of non-terminal rule. Why? Need to check the grammar for the subroutine call. Okay, just a subroutine name, this, and expression list. No. It can't be of type 3. How is it of type T? Type 3. It should be here. This is incorrect. Because subroutine call consists of a subroutine name, wait up, we were supposed to create two versions of this parser, one expressionless and one with expression. It doesn't matter. But what about this subroutine call? How the hell are we not supposed to have it inside a separate compile method? Subroutine, because it consists of a subroutine name. Well, yeah, I get it. Subroutine name is to be printed directly, and this is to be printed directly, but this expression list, oh, what? Wait. Yeah, so we need a separate function for expression list as well, right? Yeah, of course. No. Subroutine call must be inside the third type of rule. So we do need a separate method for subroutine call. So what should we do? Okay, first we have to get the next token. KZ advance, and this token will be subroutine call, subroutine name. Subroutine name is just an identifier, right? Yep. Well, whatever it is, we need to call subroutine. So subroutine call. So we'll do self dot compile subroutine, not son. Why am I typing son? Subroutine. Is this correct? Yeah, the spelling seems correct. Subroutine call will pass the next token. Okay. And after that, we can do this. Well, this should be here. We'll advance the token, and this token will be a semicolon. We'll print it, right? Okay, that will be it for the compile do statement. And after that, the final compile method, well, not the final one, but still the final in the combo of this statement. Final one will be compile return statement. Return statement return. We will do this. This is return. After that, we advance token and we'll have an expiration. Whoops. So we should probably call expiration. Not just expiration, compile expiration. Right. Okay, and finally we will have this. It's just part for the return statement. Okay, now we need to go back and look which methods did we missed. Compile variable declaration, then we started with compile let statement. We are done with let, we are done with if, while, do, and return. Inside the variable declaration, I think we don't have any left. Now we need to check this individual methods. For the let, compile let, we have compile expression. We haven't yet returned the compile expression, or we can check this table as well. So for the let, we have this expression. So yeah, we need a compile expression. And for the statements, well, I guess for the statements we already have the statements. Statements will be of this type, so nothing remaining there. Now we have the subroutine call, we have expressions, we have a subroutine call. Yeah, those two methods are remaining. 97. Okay, while it is loading, let me take a break. build a basic compilation engine that handles everything except expressions. Okay, but how is it supposed to work then? If we don't have expressions, okay, so instead of expression, we just have a constant. Is that it? Let me check. This is the subroutine call, right? So yeah, we do need a subroutine call method anyway. So but we should teach the expression list and expression. Okay, so before we write the expression, compile expression method, we should write subroutine call method. Then we'll unit test our should do now. Let's create the subroutine call method. Define compile subroutine call token. Right. So this method subroutine call, yeah, first let's print this. Subroutine call. Okay, now we have a subroutine name. Wait, we can either have a subroutine name or we can have a class name and a variable name and dot and subroutine name. Right. So what does this mean? Yeah, we can just print whatever there is. So let's do this. But this should be, it could be either a subroutine name or it could be a class name or a variable name. Now we'll do token equal to tkz advance. Now it could be a dot or a symbol. If it is a dot, that means the next token is a subroutine name, or else it is a so if token equal to a dot, in this case we should print a dot as well as subroutine name. After that we'll have to unst the token here. Now this token print it, and the next will be the expression list. So we'll have to call, wait, we need to advance it. And after that it could be empty as well, right? So we need to check if this next token, if token equal to, well, not equal to this, then we know it is an expression list. So we can call self dot compile expression list. We'll pass the token. Okay. Or else finally we'll print this. All right, Okay, but we still need this expression list now. So after this, we'll write the expression list, compile expression list cell token. Okay, let me copy this. Okay, expression list. Now inside expression list, we can have one or more expressions, right? So what should we do here? And while token not equal to this, right? While the expression list is not exhausted, we will call expression, not just expression, compile expression token, right? Now we'll check if, wait, first we need to increment the token. Wait, no, this is not correct. After I have called the expression, Yeah, so I should call it here first, and after that I should increment the token first expression. After that, when we advance the token, in this case we will either have a comma, in which case it means that we have another expression after it, or else it will be just this, I think. Will it be this rounded bracket? Where else does this subgroup expression list? It is inside this subroutine call. Where else it is? Well, it isn't anywhere else, I think. So it will be all right. Okay, so then the next token will be either comma or this. Okay, so when we advance it, we can call this while token not equal to this. What we need to do, okay, we need to print the comma. This will be the comma. Right, after that we'll advance the token and we'll call this expression again. Right, okay, what the hell is this? Don't need this. Okay, so expression list, we have an expression, we print the comma, then we advance the token, we pass the token to the compile expression, then we advance it again. Now we check if this token is this. If it isn't, then we know we haven't reached the end of the expression list yet. But when we do reach the expression list, we need to call backward again, so that we can print this in whatever compilation method called this expression list method. So if it was subroutine call, then we can print this. So we need to do this backward. Okay, so now we need to write the compile expression method. I think this will be the final method, or maybe not. But for first stage, for the basic version, we don't need any other method. Compile expression. Thanks. Expression. Before I write the expression method, let me check the output. What should be the output for the expressionless? Expressionless square. Main t. Let's check main.xml. Do we have expression or something? Yeah, we do have expression list. Okay, so the inside expression we are just printing the term and the identifier. Okay, so I think we still need to write the term compilation. Check the rules. Where are the rules? Oops, we are at the end of the slide. Where are the rules? Okay, I see. We still need the term part, but as it will be an expression less, we won't be having we won't be having op term. It will be just a single term. Well, you know what, we should end the stream here. Maybe we'll continue after an hour or two, or maybe tomorrow. So continue from here. Okay. Right then, I will see you guys in the next stream. We'll continue from here. We'll write the expression part of it and test our program. I'm sure we'll be having many bugs and errors, but we'll solve them. So till then, have a nice time. Bye bye.